Hi, this is a mini lecture on igneous rocks. I will touch on the key concepts, assuming that you will be watching and studying the videos included in your text and lab book, which will get into what I cover here in more detail, plus many other things that I'm not going to discuss in this lecture. Igneous rocks, using texture and composition to identify the igneous rocks and to determine their origin. Let's start with the rock cycle here. I've zoomed in on the igneous rocks portion of the rock cycle, which must start with melting. Melting of any pre-existing rock, whether that's sedimentary, metamorphic, or igneous, does not matter. Melting happens under unique conditions close to the Earth's surface. Contrary to what many might believe, there's not much magma inside the Earth. It's actually difficult to make magma, and you need to have just the right geologic conditions in order for a rock to melt. We'll get into this in more detail when we discuss plate tectonics and volcanoes. So melting makes magma. Magma is less dense than the surrounding rock that it was melted from and will rise slowly up through the crust. When it cools enough, crystallization can happen. Crystallization is the act of the atoms of the elements contained in the magma arranging themselves into an orderly, regular pattern which will create a mineral crystal, hence the term crystallization. This can only happen when the magma or lava, if the magma comes out onto the Earth's surface, has cooled enough and the magma or lava has lost enough energy for the atoms to arrange themselves into a crystal structure. Igneous rocks form or originate either above ground or below ground. If the magma rises all the way up to the Earth's surface and then is released through a volcanic eruption, the lava, which we now call it, or pyroclastic material, which is the ash, that gray smoke that you might see coming out of a volcano, when that cools and solidifies, it's going to form what we call an extrusive igneous rock, because the material, the lava or pyroclastic material, has exited the Earth and is on the Earth's surface. In contrast, magma that's inside the Earth that solidifies to become an igneous rock is called intrusive because it's inside the Earth. So these are the two main origins for an igneous rock, either above ground, extrusive, or below ground, intrusive. Identifying igneous rocks. Igneous rocks are identified or classified according to texture and composition. This is how we come up with the name for an igneous rock. Texture is the look, not the feel, of a rock. Texture is a term that we in our everyday lives might associate with how something feels, but not for rocks. The texture is based mainly on the size and shape of the grains contained in the rock. These are the little pieces of stuff that we see in a rock. For an igneous rock, these little pieces are minerals or mineral crystals. The texture is based on the rate of cooling more than anything else. If the rate of cooling was fast, you're going to have small mineral crystals, giving the rock a fine-grained texture. This happens when you have a volcanic eruption and lava is flowing onto the Earth's surface or is getting blasted out of the volcano as pyroclastic material. The lava has gone from being over 1,000 degrees when it was inside the volcano to now being exposed to an environment where the temperature is, say, 80 degrees. So it cools very quickly, and the minerals don't have much time to grow between before the time that everything is solidified. So you end up with a fine-grained or small crystal texture. In contrast, magma that's cooling within the earth deep underground is insulated, and the rock around the magma is probably close to the same temperature as the magma. So the heat is being released very slowly, and the mineral crystals have a long time to grow before the entire body of magma has solidified. This results in larger mineral crystals, or a coarse-grained texture. The other component that we look at is the composition. The composition is what the magma or lava is made of. And we have three main categories. Your book and lab will discuss four, but the three that I have listed here are the most common ones and the ones that I am concerned with you knowing. Felsic is the term that we give to magma or lava that is highest in silica and lowest in iron and magnesium. Because it's low in iron and magnesium, felsic rocks are going to be light in color. Be thinking pinkish, very light gray. In contrast, mafic rocks are lowest in silica, highest in iron and magnesium. This makes them dark in color. Be thinking black or dark green or very dark gray. And if you're somewhere in between, we call it intermediate silica, and color. Be thinking gray. So that's it for this. Get into the videos that you'll come across as you go through the module for more details.